Hi there, this is a Year 13 A-level maths topic called Binomial series. We've already looked at these, but now we're going to be multiplying them in what would be described as a compound expression. So let's crack on, we've got lots to get through. So my first example, if you look at it, has some function which I want to expand. On the face of it, doesn't look anything like the kind of expressions we've seen over here. Well, that is until I show you this hint which I've written here. It's x plus x squared over 1 plus 3x all squared. Needs to be written as x plus x squared times by 1 plus 3x to the minus 2. And that changing it to this negative power allows me effectively to then work things out. So I suppose the first thing I need to do is to work out 1 plus 3x to the minus 2. And as I've done previously, I just highlight that my n equals minus 2 in this expression, and my x can be thought of as being 3x. So if I chuck all that into my formula, I get 1 plus my nx, 1 plus my minus 2 lots of 3x. And then I've got plus n, which is minus 2, n minus 1 minus 3, over my 2 factorial, of course, but times by my 3x squared. And then my final one, because it only says go up to x cubed, so I think I can probably stop there, is minus 2 minus 3 minus 4 over 3 factorial times by my 3x now cubed. So if I just work those out, I get 1 minus 6x. Now that is minus 6 divided by 2 is, actually it's plus 6 divided by 2 is 3, times by 9, I reckon 27x squared. Now that 3 factorial is 6, that disappears with that 6 there. So I reckon this is probably a negative here this time. And it's, well, so obviously 27 times by the 4, well, 108. But I reckon a minus 108 x cubed. And having done that, I now need to multiply it. Now I've got a bit of space here. So I said my trick was to times it by then the x plus x squared, because that was on the top, times by this. So I reckon I can write x plus x squared times by, now what was it? It was 1 minus 6x plus 27x squared minus 108x. That's what I think it said. 108x cubed, sorry. So when I multiply this out, what's it actually want? It wants up to x cubed term. But actually, I don't think I needed that 108x cubed after all, because I'm multiplying by x plus x squared, and I think I'll get a lot of higher powers. So anyway, if I multiply it out, I get x minus 6x squared. What's that? Plus 27x cubed, and the x one I don't need because, well, the power would be too high. So now I can go on to the next one, the x squared times by all of these things, and x squared times by over 1 will give me a plus x squared. And x squared now by this minus 6x will be minus 6x cubed, and that obviously now gives me effectively an x. And notice again, I don't need the other ones because straight away I'm into x to the 4s and stuff. Gives me an x minus a 5x squared, and that's a plus 21x cubed. So if we just check our answers, 1 minus 6x plus 27x squared minus 108x cubed. That's what we got for the first part. But then when I multiplied it out into my expansion, x minus 5x squared plus 21x cubed. And obviously what I need to also do is say it's valid for these in this range. So obviously we did our expansion initially. If we just cast our minds back to our expansion was 1 plus 3x. So here we can say that mod 3x is less than 1, or mod x is less than a third. Second example then. So I've got 2x plus 5 over x squared minus 1. So this is what I want to do. This is the original function. But again, notice I'm actually giving you another big clue. I'm saying by writing this as this. So they're saying I can write that as that. Now let's just try and spot the differences. Straight away I notice it says minus 2x minus 5, and this says 2x plus 5, and this is Now, there's a reason for that. Let me just go through that. Now, I suppose if we use the trick that we used just now, I'd say 2x plus 5, and I times it by the x squared minus 1 to the minus 1, which is all very good, apart from, of course, I want to have a 1 at the front. That's what I always have in my expression. So straight away, I suppose they want to jig this about a bit. So it might be easier for me to play around with the fraction first. 2x plus 5 over x squared minus 1 is equal to, I want to make the bottom say 1 minus x squared. And in order to do that, I basically have to times the bottom by negative 1. And that way both bits become the opposites, and you just better able to change the sign, the order. But if I'm going to times the bottom by minus 1, I've got to times the top by minus 1, and that's why I get this. And that's why it can be written as minus 2x minus 5, and now 1 minus x squared to the minus 1. So it's definitely not this way. This is the better way. Okay, so I want to do 1 minus x squared to the minus 1. How do they want me to expand? Find the expansion as far as they determine x squared. All right, x squared is quite low, really. Usually go to x cubed or something, but let's do this anyway. First of all, my n, I suppose, is minus 1. My x term here is, well, it's minus x squared. So just be aware that the minus matters. So anyway, so if I put this into my formula, I get 1 plus nx. N minus 1 times my x is minus x squared. And I think all the others are just going to be superfluous. I don't think I need them at all. So actually, that's just give me 1 plus x squared. And so coming back to my suggested way of doing this minus 2x minus 5, I've got this bit now. I just need to multiply it by this. So I've got minus 2x minus 5. And I'm timesing by this expression, which I've now really have approximated with a 1 plus x squared. And it says multiply this out. So, okay, let's do this. So whatever I get is an approximation, which is roughly equal to minus 2x times 1 is, well, obviously minus 2x. Minus 2x times x squared. Now, that's an x cubed term, so I don't even need to bother with that. So this one is, so I've done that one. I've done minus 5 times 1 is minus 5. And minus 5 times an x squared is minus 5x squared. So what's that in? That is minus 5 minus 2x and minus 5x squared. Don't know if that's right. Let's just check that. Yeah, I've got it right. So an unusual one, but you know, it's a trick that we may never see again. This, by the trick, I mean this times in top and bottom by minus 1. Okay, so here's another example. Use partial fractions to show that can be written as that. Oh, it's a part A as well. So, all right, and I'm going to start off with partial fractions. When you've got a quadratic term like this, really you should try to factorize the bottom first so you know what the fraction should be on the bottom. And if I factorize that, I reckon I get x minus 1 and x minus 2. That sounds as if it would give me that. And no, interesting, it's not the same as that, but I'm going to carry on with what I've got. So I'm going to say 1 over x minus 1, x minus 2. And I want partial fractions, so that's the equivalent of a over the first one plus b over the second one. I'll worry about the fact it doesn't say that in a bit. Okay, so let's just do that then. So, so this is equivalent to, well, I suppose a lots of x minus 2 plus b lots of x minus 1, and you probably know by now that that's effectively equivalent to 1. And then I can set x equal to different numbers, and 2 is the obvious one to do for this one, and that would mean 1 is equal to, they disappear, 2 goes into e is equal to b, and if I set x equals to 1 instead, then 1 is equal to, what have I got? 1 in there gives me minus a. Or said differently, I suppose, a equals minus 1 and b equals 1. And therefore I can rewrite my initial expression, 1 over x squared minus 3x plus 2. Now, I wrote it into this format, so a is minus 1 over x minus 1. plus b was 1 over x minus 2. And you straight away realize it's not the same as the bit at the top. So they again have gone for this idea of getting the 1 at the front of the expression. So, okay, and so I need to change that to a 1 on the, that's got to say 1 minus x. And you'll notice in order to do that, I have to times that by minus 1 on the bottom. And luckily, when I times the bottom by minus 1, I times the top by minus 1, I reckon 1 over that. Now, this one's slightly different in as much as I'm going to get a minus 1 over 2 minus x. And you'll notice that on there, then, I've got a 2 minus x. I suppose I can more easily write that as minus 1 over 2 minus x, which is, of course, what they wanted me to write. So what's it want? So this part B then, it says, hence find an expansion for f of x as far as the x squared term, given the values for which it is valid. So I always miss out that bit, but you definitely get marks for that in the exam. So what did we have? We had, that was it. We had this 1 over 1 minus x. Yeah, let's just write that again. 1 over 1 minus x minus, and that's important as we remember, so minus 1 over 2 minus x. And of course, what we need to do is write both of these things as series. And now they've got ones at the front, or numbers at the front, at least we can. So it's 1 minus x to the minus 1 minus a 2 minus x to the minus 1. And the first one I'm going to do over here, 1 minus x to the minus 1. Is, well, my n is obviously minus 1, and my x is minus x. So chuck it into my formula up here. I get 1 plus a minus 1 times minus x. That was easy enough. And then my next term is plus minus 1, take away another one, minus 2 over 2 factorial times by the minus x squared. So what's that give me? Well, it definitely gives me 1 plus x. That will disappear. That disappears. Well, actually, it's just 1 plus x squared if you do it. And the other one I need to do is 2 minus x to the minus 1. Now, first of all, you remember you've got to take the 2 out as a common factor. So that's like 2 minus x over 2 to the minus 1. Now, lots of people forget to do this, but the 2 is also to the minus 1. So I've taken the 2 out, I've done all the power stuff, and 2 to the minus 1 is a half of this thing here. So I suppose ultimately I'm going to work this out and then half it. So n here is going to be minus 1. My x for this time is equal to minus x over 2. So if I chuck that in, I get, well, a half of, let's not forget that half of, and it's 1 plus nx minus 1 times my minus x over 2, and then plus my minus 1 minus 2 over 2 factorial, which is 2, and then times by that minus x over 2, and I've got to square it. So what's that gives me? It gives me a half of 1. Now that was minus 1 times, so that's like plus x over 2. And then that's 2 divided by 2, that disappears, and that is just plus x squared over 4. And of course I've got to subtract, not subtract that yet, I've got to multiply it first by a half, so that's a half plus x over 4 plus x squared over 8. Now the bit I said about subtracting comes from up here. It says you get your first answer, which is over here, and you subtract your second answer, which is over here. So I get 1 plus x squared, and I have to take away a half plus x over 4 plus x squared over 8. What's that give me? I reckon that's a half. X minus x over 4 is plus 3/4 of x squared minus effectively an eighth, so that's plus 7/8 of x squared. Now the one question is validity. On this one, I suppose this one's just mod x is less than 1. This one is, well, this is what we ended up doing. This is x over 2 modded is less than 1, which is another way of saying x is modded is less than 2. Now, we can't both be right. You take the weakest one. I reckon mod x is less than 1 because it's got to be less than 2 there and less than 1 there. So my answer is that, and in class we will have a look at some questions.